Welcome to 2.3 Trig Derivatives. So we're going to introduce the trig derivatives in a couple of different ways. The first wave that we're going to introduce them in is just sine and cosine. So the derivative of sine and cosine are kind of nice because the derivative of sine is cosine. And as much as we want the derivative of cosine to be sine, it's not. It's negative sine. So what does everybody always forget? The negative. So the derivative of sine is positive cosine. So sine turns into cosine. Cosine turns into negative sine. And I'll show you a picture here in a minute that talks about why that works out that way and some of the features. So when you take the derivative of trig, it's very similar to when we were taking the derivative with function notation. If I have a number in front of my trig, that number sticks around. And then I just take the derivative of sine. And according to our rule, derivative of sine is cosine. And that's all you have to do. So then I'm going to take the derivative with respect to x of negative 3 cosine, which means I'm going to have negative 3, stick around. The derivative of cosine is negative sine. And the two negatives churn out a positive 3 sine of x. When you have terms along with your trig, you take the derivative of the terms separately from the trig. So the derivative of 1 is a constant, so that's going to be 0. And then 2 sine of x is just like the one that we just did right above it. We're going to carry the 2, and the derivative of sine is cosine. So we end up with 2 cosine x. Same thing with x squared plus cosine of x. I'm going to go ahead and take the derivative of x squared using the power rule. So x squared turns into 2x. And then the derivative of cosine is negative sine. And so if I clean this up, I get 2x minus sine of x. Then I'm going to take the derivative of negative sine of x minus 4x to the fourth. So that's going to give me the derivative of sine is cosine. The negative sticks around, so that's going to be negative cosine of x. And then I'm going to have minus 4 times 4 is 16, so this is the constant multiple rule. And then x to the 4 minus 3, which is 3. For the next one, I have 3 terms, so I'm just going to go right down the line. I'm going to say the derivative with respect to x of 7 cosine of x. So the 7 sticks around. Derivative of cosine is negative sine of x. Plus 8x to the 1/2. I'm going to do 1/2 times 8, which is 4. X to the negative 1/2. And then the derivative of 5 is 0. Cleaning this up, the first one is going to end up with negative 7 sine of x. For the next term, I'm going to fix that negative exponent. I'm going to take the x to the negative 1/2 and put it in the bottom, making it a positive exponent. And then I don't need the 0. The next one is asking the same thing, but it's phrased differently. All of these on the first page are saying, what's the derivative of the following? This is just saying, here's your function, find the derivative. So same idea, different notation. So to find the derivative of y, I can use y prime, or for good practice, I can use dy dx. The derivative of sine is cosine. The derivative of cosine is negative sine. And so I'm going to go ahead and say cosine of x minus sine of x. For this last one, it's similar to the one that we just did, except it's sine of x minus cosine of x. So I'm going to say f prime of x. Derivative of sine is cosine. And then we're going to say minus, and then derivative of cosine is negative sine. So we've got cosine of x plus sine of x.